Okay, so in the previous question, we tried to solve an example of a dimensional analysis, which was saying like we have to check if the equation that was given was dimensionally correct. Now, in this case, using the same principle of homogeneity, how can you solve questions that are given like this one, whereby they're saying a physics student conducting a laboratory experiment on kinematics drives a formula of velocity v of an object varies with time expressed as v equal to a t squared plus bt plus c, where velocity and time are expressed in terms of SI units. Determine the units of constant A, B, C, and D. So we've been given this expression whereby they're saying V is equal to A t square plus B t plus c. So whenever a question has been posed like this, what do you do? Following the principle of homogeneity, whereby we're saying what is on your left hand side must be equal to what is on your right hand side. That actually means that I'll start having the dimensions for each and everything. So in short, I have to equate v equal to this, v equal to that, and finally v equal to c. So before I do that, I need to know the dimensions for t for each one, which is for t as well as for velocity. So here I'll write dimensions for v and t. So for v, its dimensions are what? Meters per second, which is L t to the power negative 1. And then for t, we know that this one it already have the dimension of what? T in a form of dimensions. So here, since I said like if you want to check or maybe you want to find the values of A, B, C, you have to equate what is on your left hand side be equal to what is on your right hand side, meaning that this dimension I have to equate it to this one also to that, and this one to that. So I'll say L t to the power negative 1, this should be equal to what? A t square. So remember, for you to find the dimensions for A, you have to divide throughout by what? T square, this one by t square. So you divide, we're going to have A equal to, this is going to be L t to the power negative 1. Then this one, whenever it goes on top, it is going to be multiplied by t to the power negative 2. So what you are saying is you can have the rule of indices whereby you're having the same what? Bases. So what does it mean? You find that here these two can be taken as one thing, and then you add the powers, and the dimensions for A will be equal to what? Will be L t to the power negative 3. You are done. You come to B, you do likewise by equating this to what? To that. So I'll say for this one, I can write it from here. I'll say V has to be equal to what? B t. We know the dimensions for velocity. We also know the dimensions for what? For this other one. This actually will be written as what? Dimensions for this one, which is L t to the power negative 1. This has to be equal to what? To say B dimensions of t. Okay, so if you divide throughout by t, even that side by t, you understand that b will be equal to what? L t to the power negative 2. Then for c, what you're going to do, you do likewise by just relating to say c has to be equal to v. So c in this case has to be equal to what? The dimensions for v, which is velocity. Then you put it in a form of dimensions, and you're going to find that they're going to be written like L t to the power negative 1. Thank you.